I want you to just, for a second, close your eyes. Picture yourself at the beach.
Okay, I am there.
You're standing, say, waist deep in the ocean. It's a sunny day, and you can feel that push and pull of the water.
And you see a big wave starting to form way out there.
Now it looks like all that water traveled miles just to get to you.
It certainly feels that way. But that's the big illusion, isn't it?
It is, and that's the secret we're diving into today.
Learn it fast, learn it fun, 711.
The water you feel, it didn't actually travel from the middle of the ocean.
Right, we think of a wave as a big wall of water moving forward. But physically speaking, a wave is really just energy. It's energy moving through the water.
So the water is just the delivery truck, but the energy is the package inside.
That is a perfect way to put it. And that's true for any wave, really. Whether it's in the ocean, or sound, or even light.
I think I have a good way to picture this. Imagine you have a long rope, like a jump rope. You tie one end to a doorknob, and then you just snap your wrist up and down once. You see that little wiggle travel down the rope?
And that wiggle has a shape. A very specific shape that scientists have names for. Very, very top of that little bump. It's called the crest.
And the lowest part, the bottom of the wiggle, is the trough.
Right, crest and trough. Now, if you want to measure how long that wave is, you'd measure from one crest all the way to the next crest.
That's the wavelength.
Exactly, it's the wavelength.
But you know, if I'm at the beach, I'm not really thinking about wavelength.
I'm worried about how tall the wave is. Is it going to crash over my head? And that's what we call amplitude. It's basically the height of the wave from the middle point up to the crest. You can think of amplitude as the wave's strength.
So a tiny little ripple has a really low amplitude.
But a huge tsunami has an enormous amplitude.
An enormous energy. Don't forget to grab your free PDF resource. Link in the description below.
Let's go back to this idea that the water isn't moving forward.
Let's picture a quiet pond this time, and we throw a small rock in. Now let's say there's a little rubber duck floating in the pond. When those ripples, those waves get to the duck,
what happens? Does it surf all the way to the edge?
No, it doesn't.
And this is the proof. The duck just bobs, it goes up, and then it goes down.
It stays in the exact same spot, because the water under it is basically staying in the same spot.
The water particles are actually moving in a tiny circle. They go up, forward a little down, and then back to where they started.
So it's like each little bit of water is playing tag with its neighbor. It just bumps the next one and says, "You're it."
That's a great analogy. It passes the energy along, but each water particle stays in its own little neighborhood.
And that's how energy can travel for miles across the deep ocean. But things change when it gets close to the beach, right?
Right, because waves at the beach definitely crash. That water isn't just bobbing anymore, it's falling over. And that happens because the water starts to run out of room.
That's right. Out in the deep ocean, the wave has plenty of space underneath it. But as it gets closer to shore, the bottom gets shallower, and the bottom of the wave starts to drag on the sand.
Precisely. Friction kicks in. It's like, imagine you're running really fast, and suddenly your feet get stuck in thick mud. Your feet would stop, but the top half of your body would keep going, and you'd fall right over. That is a crashing wave. The bottom slows down, but the crest at the top is still moving fast. It gets too tall, too steep, and it just trips over itself.
Which is the exact moment a surfer is waiting for. A surfer is basically an energy hunter. They're looking for waves with high amplitude tall waves, because that means there's a lot of energy there to push their board.
And when that wave finally crashes onto the sand, all that energy is released. It can move sand around, build things up, or wash them away.
And that's the end of the energy's journey.
The water itself just slides back down the sand, waiting for the next push.
So next time you're at the beach, just remember, you're not really watching moving water. You're watching invisible energy that has traveled all the way across the ocean.
Absolutely. Here's a final thought for you. We know ocean waves are energy moving through water, but what about sound?
Sound?
Yeah, how is the energy from my voice getting to your ears? Are the little particles of air flying across the room, or are they just bobbing back and forth? Kind of like the rubber duck at the pond.
711, what's your emergency? Why? 711, why? Yeah! It's 711. Yeah, we're on the line. Science help is here, and we're right on time. Got a question?
Call it out.
Let's begin. We learn it super easy. Come on, jump in. 711, 711. Big ideas made simple for you.